Hello friends, welcome to our channel Knowledge Amplifier. So today in this short video tutorial we are going to explore one very interesting system design concept, and that is video bookmarking. So if you check the YouTube platform, and here I am having my channel open, if you observe the videos, here some red color lines are going, right? So if the red color line is complete, that means I have completely watched the video. But if you consider this particular video, the red color line went only up to this, right? That means up to this I have watched the video, and this particular part is not watched. And that generally happens when you watch videos in any platform, whether that is Disney, YouTube, Netflix, etc, etc. That is, it might not happen that I am watching the complete video at a single go. Maybe some part I have watched and then I have some important work came in middle. I paused the video or closed the platform and completed my work, and then later some point of time when I will open the video, the expectation is the system should be intelligent enough that it will start playing the video from where I finished last time, right? That is, if you observe this particular video, this should start after this specific position. It should not start from beginning again. So basically, in a way, the system should be having a track that up to which position for a particular user a particular video is watched, and that concept is nothing but called as video bookmarking. Although there is no book concept available here, it can be in a better way called as video marking or 𝑽𝒊𝒅𝒐 kind of something, but in system design world we call it video bookmarking. So now in this particular video we are going to explore how simply using few AWS services we can easily build this kind of video bookmarking system, which will be having a track up to which a particular user has watched a specific video, and if user next time try to play it, then the video should be played from that particular position only where user has stopped watching earlier. Okay, so here I'll be going to my Draw.io platform, and here we will consider that our user is watching the video. So maybe here let me search some streaming platform like Disney or something if it is there, or maybe YouTube only I can search. Yeah, YouTube icon is there. So this is basically kind of our streaming platform or application in a way we can say. So kind of in system design world we call it client. Okay, cool. And here some user will be there who is suppose watching a specific video. Okay, right? Now, what this particular application should do, ideally try to understand that in some backend database for a specific user, for a specific video, the position need to be continuously updated. That up to this position, the user has watched the video, right? And who will transmit the data? From this particular application, that is YouTube, which is basically installed in user's machine. From there to our company YouTube, this particular YouTube application should be continuously sending the telemetry data, which contains the information that user has watched the video till this position, right? So maybe what the application can do here, let me find out API gateway. So this particular app can send this kind of telemetry data to API gateway. That is, API is built using API gateway, right? So here our API gateway is there, here our client is available, and here is our user. Okay, cool. Now what this particular API should do, this API should have an entry in some database, and in serverless world a very popular database to store this kind of information is DynamoDB. So I am going to choose DynamoDB in this case, trying to keep the same shape as of now. Somewhere here our DynamoDB will be there, which will be our backend database, right? Till this layer I hope it is pretty much simple. Now this API gateway, how it will make an ingestion in DynamoDB, that is the question. And in AWS, as we know, that API gateway can directly interact with DynamoDB also, but we should not directly having a setup or connection between API and DynamoDB. Rather, what we can do, we can put some streaming platform like Kafka or Kinesis in middle, so that if other application in your organization want to consume the same data, they can easily consume. Because if you recall the fundamental concept of Kafka or Kinesis, once the producer write the message in a topic, multiple consumers can consume the messages, right? So here I can put some streaming platform like this. So maybe Kinesis I can search, and here Kinesis data stream I can pick up. So the API can write the data in Kinesis. So here I can write Kinesis data stream. I hope you are following me till this layer. Just user is watching the video. Here the application need to continuously send that for a specific video up to which position the user has watched, and to send that client may be calling a API with post request and pass that data, and that API will write the data in Kinesis data stream. So API gateway and Kinesis data stream integration also directly possible, which I have already covered in my previous video. The prerequisite links I'll be sharing in the description box. Okay, right? And now from Kinesis the data need to be written in DynamoDB. So we can easily use Lambda in middle for event driven workload. So here our Lambda will be there. Maybe this DynamoDB I can shift little bit right, and here our Lambda will be coming, and here Lambda will be consuming the data from Kinesis via polling mechanism, and then we'll write to DynamoDB, and here I can write Lambda. Yep. So this becomes one particular side of the architecture. This one we can name as, here let me give a box, and this one can be called as update position. This particular section of the architecture just responsible for updating position, that up to which location or position the user has watched a particular video. So this is update position side of our architecture. Now once user next time open the platform, then he or she should be having this visibility that up to which location or position the user has watched, right? So this application is directly fetching that information from this backend database. So that one we need to have also. So that service can be a very simple application. So here client will be, that is our YouTube application, will be calling the API maybe with another resource path. So here our API will be there, and that API will be going to Lambda like this way, and then Lambda, what this Lambda will do, the Lambda will go to DynamoDB to fetch the information that this specific user for this specific video up to which position they have watched. Okay, and then this YouTube application need to intelligently draw this particular line starting from 0, that up to this position the user has watched the video, and if user click on the play button, then what will happen, automatically from that particular position the video should be played. Okay, right? So here this particular side of the architecture we can name as maybe get position. Okay, get position for a particular video for a particular user. So this becomes our simple video bookmarking service architecture. And now another very important part is how the data model for our DynamoDB will look like. So that let me draw here a little bit. So I'll be taking pen, and the DynamoDB table structure can be something like this. We are having two kind of keys concept in DynamoDB. One is partition key and another one is sort key. That is, partition key is based on which the data will be partitioned, and sort key is within that particular partition the data will be sorted based on which key. So that is sort key, and together partition key and sort key should be kind of composite primary key with respect to normal database world you can think of. So here in this case our partition key will be there, and then sort key will be there, and then position, that up to which that particular video is seen, up to that, and then maybe we can have one more column called timestamp, that is at this specific timestamp the information is updated. So what this partition key will be in this architecture. So partition key is based on which the data will be partitioned. I hope you are getting this. It is pretty much intuitive if you observe this diagram, that user is basically someone for which we are creating this specific flow. That is, user is someone who is the central primary entity. That is, if I am watching the video and if you are watching the same video, for both of us the video bookmark will be different position. So we can say here partition key is user ID. So I can maybe write here user ID, for example user 123, okay, and then maybe user 456 and so on. Like this way the partition key we can consider as user ID. Now one specific user can watch multiple videos, right? In the YouTube platform, if you see here, this video, for all the videos the bookmark need to be saved, right? So for that, what we'll do, we will consider for each video there is some unique keys there that we can consider as short key. So maybe video title if we consider as primary key, so title 01, for that we need to store the information, then title 02, for that we need to store the information, title 03 and so on. Okay, so together for a specific user, for a specific video, the position should be one single value. So kind of these two key combinations are making our primary key in this DynamoDB table. Okay, right? And then we need to store the position that this client application, for example, that can be YouTube, Disney, Netflix, etc. They have transmitted that up to position 1, 2, 3, 5 the user has watched the video on 10:02 AM 20/07/2025. On this date, up to this position the user has watched the video, and this particular row need to be updated continuously by our client application. That is, for example, if I am watching the video and the video duration is starting from 0 to 5 minutes, so first what the application will do, when we'll start playing the video, it will have an entry that for this user, for this particular video we title 01, the position is 0 at this specific time. Then suppose that user has watched till position 20 at specific time A, then this particular row should be updated, that position should be 20 and the time should be A. Then if the user has made some more progress and maybe the position is now maybe 125 at time B, the client application should need to basically call the API and update the DynamoDB table that for this user, for this specific video, current position is 125 and the current time is B, like that way. For a specific title, for a specific user, always that single row will be continuously updated, and in the position it will be having the latest position alone. It is not like each time a new row will be created to track the position, and in timestamp column it will be having the information that when it was last updated. But if suppose you want to have a track that user's complete journey, if you want to have some information like at this specific time that position, at this specific time this position user has watched, then you no need to change this particular data model much, because DynamoDB has stream feature itself which can help us in capturing CDC or change data capture, right? So let our video bookmarking application only update a single row, but each time a row is updated we can capture that particular information via CDC, and from DynamoDB we can forward that to Kinesis data stream, which is another data stream, not this one, and from Kinesis data stream we can transmit that data to Firehose for batching purpose and then dump the data in S3, from where using Athena if needed we can query. So that data lake model we can easily implement. But for our this specific video bookmarking model, for this DynamoDB table, this particular data model can be followed, right? So I hope in this video the fundamental concept of video bookmarking is clear to you. All the relevant programming implementation related videos I'll be sharing in the description box. You can go through that. That way you can easily build this particular project completely end to end, right? And if you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.